Hello. We want us to check the through this vector. It's a very good question, by the way. It's a question which is covering it's cutting across so many curriculums. But then possibly I want us to check through this one. It's having the basic vectors and it's also having the complex vector, all of them combined in one step. So I want us to check through this vector. Is a vector of parallelogram. Most of you are used to vectors of triangles, but then let's use this one because it covers a lot of things at the same time. So we are provided with a vector. In the diagram, OAB is a parallelogram and OP and CA intersect at X at the center of the intersection. And see the ratio of CP to PB, we can see the ratio of CP to PB is um, 2:1. Therefore, here this is 2 and this is 1. And furthermore, we are also told that OA is vector A, OA is vector A, and OC is vector C. So we are supposed to find OP in terms of A and C. OP from O to P in terms of A and C. So basically, for us to go to P using either A and C, one of the ways for us to know that OA is parallel to CB and therefore vector CB is also A in that direction. That is also vector A. And therefore, if we want to find OP, if we want to find OP, it's as simple as going through. So OP, we have to go through OC and then also take from C to P. Those are clear. It should also be noted that C to P, okay, OC is just vector C, but then C to P is 2/3. 2 out of 3 because there are 3 division between C and B. So it's 2/3 of vector A. Now this is as simple as that is OP, 2/3 of vector A. 2/3 means 2 over 3 divisions because from C to B is 2 plus 1, which is 3. There are 3 units. CP taking 2 of the units and PB taking 1 of the unit. So we are only interested with the unit taken by C and P from C to P. Now let's go to question 2. Now in question 2, we have this one here. Find OX in terms of A and C in its simplest form. And then we've been told that CX to XA is 2 to 3. So CX is 2, XA is 3. Total ratio is 5. So that means for us to get OX, O to X, we need to go first of all from O to C and then we go from C to X. If there is something that is not clear, we put it clear. So from O to C is C, and then from C to X is 2/5 of the total CA. You can see it's the 2/5 of the total CA. And therefore, we can now find CA. Now, CA is, we come from C to O, negative vector, and then we go from O to A. Now, C to O is a negative vector C, and O to A is a positive vector A. We are headed to the same direction with the vector. So if it's in the same direction, the vector is positive. It's against the vector, it becomes negative. Now we come and replace it on Cx. This is our Cx here. We're now replacing it here. Therefore, we can say that our vector Ox can be calculated by C plus 2/5 of the vector Ca. Now, Ca, we've seen it is as negative C plus A. Now, we can solve this one by opening the bracket, and we can say that Ox is vector C, and this C is a vector, so vector C. Now, 2/5 times, negative C is minus 2/5C plus 2/5A. Now, if we solve these vectors, C and 2/5, we can subtract it to get 3/5C plus 2 over 5a. This makes us vector x. Now this is from O to x, and that's what we are looking for. Now the next question here that we are supposed to find is to find the we are supposed to find the ratio of OX to XP. That is part 2 of question 7b, OX to XP. Now we already have OX, so what we are looking for is XP. We are looking for XP. Now in our case here, we are only looking for this one, XP. Now XP happens to be that for us to get to XP, there is the shortest route for us to use. XP is for us to go from X to C, which is the opposite vector of what we were finding CX, and then we go from C to P. Now these are the routes. These are the route we are supposed to follow. Therefore, this gives us from X to C. It's the same thing we were dealing with CX here. Where is CX? Where is our CX? Our CX is 2 over 5 CA. It's 2 over 5 CA. So this is 2 over 5 CA. So we are going to do the opposite way. So 2 over 5 CA, which is this one. Where is it? 2 over 5 CA. This was our CA, negative C plus A. So 2 over 5 CA was, we didn't calculate it, but we just opened it directly. This is 2 over 5 CA, this one here. This is 2 over 5 CA. So we are going to put it here as an opposite vector. So the opposite vector of CX, so where there is negative 2 over 5, because this one, if we opened this one, it was supposed to give us, like CA is negative 2 over 5 C plus 2 over 5 A. So we are going to change the opposite vector. Where there is negative, of course, by changing it, we are just multiplying everything by negative, and we are going to have 2 over 5C minus 2 over 5A. Now that one is CX. And then this CX, this XC, we add it to CP. Now CP, we've realized that CP is 2 of the 3 divisions of vector A. We add the common the common terms together. So this is 2 over 5C. If we add it, let me just do the addition here. Negative 2 over 5 minus plus 2 over 3. These are A, so I'm just adding the numbers as a coefficient. This is 15. We can multiply 2 by 3 to get negative 6. We can multiply 2 by 5 to get positive 10, which gives us 4 over 15. So we can come and put here as plus 4 over 15a. This is vector xp. That is direct, that is vector xp. Now finally, what we are supposed to do is to find the ratio. Now the ratio xp, we are supposed to find the ratio of ox. Actually, it's the ratio of ox is the ratio ox to xp. Now ox, in our case, ox is, it's here, this is our ox. It's 3 over 5c plus 2 over 5a. To the other vector, xp, which is 2 over 5c plus 4 over 15, 4 over 15a. Now these are the vectors. C represents C, and you can even check by, you can take any of the values to now have a common ratio. So you can just take CC, the ratio should be the same. So if we decide to take the coefficient of C, therefore we are going to have the coefficient of C for the first case is 3 over 5 to 2 over 5. Well, the bases are the same, the denominators are the same, therefore the ratio is 3:2. That is the ratio xp. So, but then you also need to confirm to be sure that the other ones also coincide. They should give you the same thing. The coefficients of A is 2 over 5 to 4 over 15. One of the things that we should do here is to make sure that we multiply by the least common multiple here. So I can multiply here by 15 and here by 15, so that this cancels out with this one. And then 5 divided by 5 is 1, and 15 divided by 5 is 3. So we're going to have 3 times 2, which is 6, to 4. You know, if you simplify this ratio, 6 divided by 2 is 3, and 4 divided by 2 is 2. So still the ratio remains the same. You can see clearly that these two ratios are the same. And therefore the ratio OX to XP is 3 is to 2. That is how simple the question is done. I've tried to squeeze them here, but then that is how simple the question is done. And it explains a lot of things. The same is applied to any form of shape that you have, as long as you have the basic understanding of the sides. You know, the parallel sides are equal. AB is vector C and OC is vector C again. OA is vector A and CB is vector A. BC is negative vector A and AO is negative vector A. Like, these things should be direct. Thank you, and continue enjoying mathematics.